Hi students, today we will be discussing computer architecture and ALU, Arithmetic Logic Unit. Okay, so this is the overall architecture of a computer, digital computer. Okay, so if you see, there are the external devices. Okay, external devices, they are entering the system with the help of encoder. Okay, so how many devices are there? So many devices can be connected. Suppose in a computer there is what are the common input devices? These are the keyboards, or this can be mouse, or there are so many other types of input devices. Okay, like joystick. Okay, so those devices are, or maybe some microphone, whatever we are telling. Right now I am telling something to you. I am giving you the lecture, so it is audible to you with the help of microphone, right? So this, my voice is getting inside the system with the help of this encoder. Okay, so these are different types of input devices are there, n numbers. You can connect so many devices. That is up to you. Okay, so after that, okay, there is encoder. Encoder means your data is analog data, outside world data is analog data. So computer cannot understand analog, it can only understand the digital. That's why you have to first basically convert it from analog to digital one. Okay, digital version, analog version to digital version conversion is required. So that's why we need the encoder. Okay, so encoder is basically change the analog data into the equivalent digital data. Okay, so this is the data line, and obviously there will be a data stream produced. Okay, for different devices there will be data stream will be produced, as you have already studied encoder. Okay, so suppose what is decimal 1? What is decimal 1? Okay, that is 001. What is decimal of 2? 010. Okay, so in this way, whatever data is coming, suppose 1 is, here 1 volt is coming. So equivalent data will be 0001. If it is 2 volt is coming, then equivalent data will be 0010. In this way, this is 4-bit data. This encoder is 4-bit encoder, so it is producing 4-bit digital data for a same for an analog signal. Okay, so in this way it will basically digitize data, and that will be a combination of many bits. That's why it is a huge, spreaded arrow. Okay, it is not a line. So that is basically the input data. Okay, so that data is going inside the CPU. Here there will be processing of the data. Okay, so for processing you need a program. According to the program there will be processing. So this is basically the memory unit. Memory unit is further divided into two parts. Okay, this is the program memory, this is the data memory. So program memory is basically in program memory, the program is basically stored. Okay, so whenever you are buying a computer, some inbuilt program, say we are using Windows, we are using Microsoft Windows, okay, Windows 10 or Windows 7, whatever it is, any version. So those programs, that means the system programs that are already stored inside this program memory. Okay, and this is only readable. It cannot write. You have no permission to change the program. Okay, so it is always readable. That's why the arrow is basically from program memory to the CPU. Okay, so the data, it is according to the program. Whenever the user will run a program, what will the CPU do? CPU will basically take the program line by line. It will read the program line by line and it will execute the instructions. It will read the instructions and after that it will execute the instruction, then it will fetch another instruction and next execute that one. In this way it will proceed. Okay. So for this, whenever according to the program, it needs to basically take the data from outside world. Okay. So then it will basically take the data from different input devices, one device at a time. It is actually working in time sharing mode. It cannot take all the input device data at a time and process. Otherwise everything will jumble up. Okay. So at a time only one is allowed to come here. One data. Okay. So for that we use a multiplexer. Okay. So multiplexer will be used. See, first encoder is there. So whatever data is coming, it will be basically coded. Okay, that means it will be converted into binary stream. Okay, the data lines, binary data lines for each of the devices. Whatever data is coming, 2 volt, 5 volt, whatever data is coming, for each and every devices, there will be particular encoders and there will be data lines. Okay. So this is a common thing. This is only a block diagram representation. For all the data, there will be basically bytes of data. Okay, that means digital data. Then there is a part here. It is not mentioned here. There is called the multiplexer. So multiplexer's job. What is the job of multiplexer? This is basically, suppose parallel data is coming. Now that parallel data needs to be converted into serial data. That means only one data line. In that data line only streams of zeros and ones are going. Okay, here it is basically parallel data is being generated. Okay, parallelly in the different. Is it clear? Okay, so parallel data is being basically generated. Now you have to convert it into serial data. And now if you use a multiplexer over here, so different pins are coming to which are basically carrying the stream of data. Okay, stream of zeros and ones coming from the different devices. Device 1, device 2, device 3 and device n. So multiplexer will be there just to choose one line at a time. That means one input device at a time. That finally it will be entering into the CPU, the data, digital data. Okay. So after that what will happen? There will be processing of the data according to the program. Okay, so for the processing part, there is basically arithmetic logic unit. Inside the CPU, there are some counters and registers along with the arithmetic logic unit. Okay, mainly it is arithmetic logic unit. That means to perform different types of operations like addition, subtraction, multiplication, division, or AND or XOR operation. Okay, or NOT operation, inverter operation. So many operations we have already studied. Okay, so that's why actually we skipped this part first. I thought that it will be beneficial for you if you first go for the different components thoroughly. Then after that, if I move here, it will be more convenient to you for understanding the concept. Okay. Okay, so after that, after the processing, for processing the previous data also may be required. So data, this is program memory and this is data memory. So in data memory, the data are stored. Suppose in a particular program, you have stored the data here. Next, you are using that data in another program. It may also happen. So in that case, this is basically bidirectional communication. That means data is coming. Okay, suppose there is no DMA, direct memory access. Suppose you forget this part. This may or may not be included in your configuration. Suppose in first you consider this part is not there. Okay. So directly the data is going inside the CPU. And it will be stored. If the data is going, some data is being fetched by the CPU, and suppose it is stored here. and another program you are running, there you need the previous data. So that data will come here and there will be processing of the data and new data can be stored here. So this is basically bidirectional communication. Or the newly processed data, after storing, you may print that data or display, it will be displayed to your monitor. Okay, so that's why monitor and printer, those things are basically output devices. So the data after processing, it will go to the output external devices, any one of them at a time, not simultaneously at every device. Okay, so at a time only one line should be selected. So what will be here, it will be the data stream is coming, parallel data is coming. So there will be decoder action. After decoder you are getting, okay, is it clear? The data is coming here and there will be another action. If there are multiple outputs, there will be demultiplexer also. That means that data, with the help of demultiplexer, this parallel data first should be converted into serial data. After that it will go to the demultiplexer unit. So in demultiplexer, so many input, one input line will be there. That means one serial data. Okay, so this data, this is a parallel data. You have to change it into serial data. That means in a single pin, the data streams ones and zeros, streams of ones and zeros will come sequentially. Okay, so it will go inside a demultiplexer here. After that, it will be converted. After demultiplexing means one into many. That means the data stream will be directed to any of the output lines. Okay, and in those output lines will be connected with the external device, different external devices. Okay, so after demultiplexing, the data stream, okay, serial data stream, zeros and ones will come in a particular line. Okay, so after that there will be basically decoder action. Okay, so there will be decoder action, and finally what will be, that means the digital data is being changed into analog data. Okay, so after decoder, it is taking the serial data, that means digital data it is taking. So that digital data will be converted into equivalent analog data. Okay, and it will go into a particular external device, one device at a time. Okay, so in this way the entire thing will work. Okay, and now come to the DMA part. So DMA part is an extra addition. So if you always go take this path only, so the CPU processing, that means efficiency, the processing time will be more, because all the time all data is entering into the memory through the CPU. Okay, there is no bypass way here. If you consider, there is no this part here. Okay, so in this way the CPU efficiency will be less, processing time will be more. So that's why there is a provision for direct memory access. That means the input data can directly go into the memory through the DMA. Okay, and similarly in the output side, from the memory through DMA it can go in the output. Okay, so this will basically save the processing time of the CPU. Okay, and controller is overall. This controller is there, a controller is there, see, it is very important. Controller is basically the organizer or manager of the entire system. It will basically manage the entire operation of this computer. Okay, so this is all about the computer, that means architecture of a computer. Okay, so in this way the computer will work. Okay, so this is all about the computer architecture. After that we can move to this one. I already told you multiplexer and demultiplexer. So many devices are there. It is connected with the mask. Okay, mask, that means multiplexer. After that it is going inside the computer for processing. Similarly the output, see. Okay,